When you look at our planet Earth from space, all appears calm, even changeless. But in fact, below the clouds, there is constant motion. Waves crash against the shores. There are waterfalls tumbling down hillsides. And even the mountains are moving. What? Mountains are moving? How can that be? We'll find the answer today. Find out too whether your local beach could end up looking like this. Dave? What are you doing, Dave?
I'm trying to think about rocks. Now, right now I can picture a solid, hard, grey ball. Hey, why don't you give it a go? See what you come up with.
I see a Martian landscape.
Oh, you're on another planet.
Yes, small, red, rocky rocks. Oh, it's interesting, isn't it? When I think about rocks, they're all much of a muchness, all the same colour.
Yeah, but when I think about rocks, they're all different colours.
You're right, rocks do come in different colours.
So, how would you define a rock?
Ah, tricky one. We need to find out more.
Where do all the rocks on Earth come from?
They come from outer space.
Are any new rocks forming on Earth?
Yes, the rocks in the Earth are always reforming to make new rocks.
Want more information? Ask an expert.
Rocks can form in three different ways. The first is igneous processes, which is usually something to do with volcanoes. The word igneous means fiery birth. We've got a couple of examples of igneous rocks here. The first of these is a large lump of basalt.
Oh, this is heavy, isn't it?
It's quite heavy. It's a rock that's been extruded out of a volcano, and this rock actually comes from the Western Plains of Victoria.
So this was actually made in a volcano, spat out by a volcano.
Spat out by a volcano.
Fantastic. And what about this one? Oh, this is so light.
Okay,
compared to this one, which is so heavy, this is so light.
Yeah, and yet they look quite similar. They've both got holes in them, but this stuff is called pumice, and it's like a froth from the volcano. It's sort of like a rock froth.
It occurs to me that if these rocks were all formed in volcanoes, we don't actually see many volcanoes happening at the moment. Does that mean rocks are not forming much at the moment?
Well, we don't see many volcanoes in Australia because the last lot of volcanoes we had were about 5,000 years ago in the Western Plains of Victoria. But around the world we do see evidence of volcanoes, but not in Australia. So rocks are still forming, but not
elsewhere.
But elsewhere.
That's how rocks are formed. But can rocks ever be broken down? How?
David, did you know that rivers play a really important part in shaping the landscape? They can actually cut through rock.
Yeah, but how do they do that? I mean, they're not chainsaws.
Do you know, I don't know. I think I need an expert to help me. Maybe I could meet someone down at Bacchus Marsh and they could explain it for me.
Yeah, but it's raining outside, you'll get wet.
I don't think geologists care very much about rain. I think they're used to working in the rain.
Oh, yeah, you're right. They probably weather any weather.
I'll see you later.
Don't forget your umbrella.
How do rivers move rocks? Want more information? Ask an expert.
To find out more, I've come here to Bacchus Marsh. And I've got a couple of clues. Here's the first one. What do you notice about the shape of this rock? And here's another clue. If you look at the river over there, You can see it's sort of cloudy on the far side, and yet on the side near me, the water is actually much clearer and is also running much more quickly. So how does that help us to understand how rivers are involved in forming rocks? Luckily, I don't have to solve this mystery by myself, because there's an expert here from Creswick Landcare Centre, and she knows all the answers. Tanya, thanks for meeting me here. Good to see you. Now, can you help me understand a bit more about the processes that are going on here? First of all, those rocks over there, how did they get there?
Well, they're called sedimentary rocks, and they've been formed millions of years ago.
And what's happening to them now as the river is running past them?
Okay, the river's trying to make its way down eventually to the sea, and so it's carving its way through those rocks.
So it's actually carrying material with it then. It's cutting material out from the rock surface and carrying it with it.
That's right. And here in my hand, I have a rock that would have been flaked off or eroded from the rock like over there.
Now if you compare that with the rock that I've got, you notice immediately a subtle difference. So
That's
why
right.
is that? What's happened here?
Okay, well, the rocks over there are a lot squarish, aren't they? And over time, they're flaked off, and they then get into the river and are moved around, jostled around in the water, and eventually they smooth down and become rounded pebbles.
So your rock was actually broken off a lot more recently, and mine has been roughed up by the river for
That's
a
right.
fair while. What about my other clue? Why is the water cloudy on one side and clear on the other?
Okay, well, the river, when it moves through bends, it will, one side will be moving much more quickly than the other side. The far side, the water has slowed down, it's a lot more shallow, and it's depositing the sediment that it's carrying. And this side, it's moving much more quickly through, and eventually it will deposit its load when it slows down.
Material is eroded or removed from one place and carried away. Meanwhile, at another location, material could be building up. Gradually, the landscape changes.
Oh, that's better, Berry. You're nice and dry now. I told you it was wet out there.
It was, but it was well worth it. I found out so much about rivers and how they cut through the rock, and also how they rub the rocks together as they carry them and round them off. Now, I had an idea for an investigation that you could try to see how this happens. If you've made some rocks, you could put them in a tin can, you could cover the can and seal it, and then you could shake the can for 2 minutes, and then have a look and see if it's changed the shape of the rocks.
The ever-changing landscape.
We've got a disaster waiting to happen here. It looks like a pretty good landscape right now, but what's going to happen when we flood this riverbed with water? Well, this landscape was actually built by Brad, Billy and Tricia from Bell Primary School. Tricia, first of all, what elements did you put into the landscape?
The plants and rocks.
Ah, very nice too. They look really effective. And Brad, what about you? Did you put something special in here?
Yeah, I put the bridge, the fence and the big mountain.
Great. Billy, what did you put?
I made the some hills, sort of some deep ones and not so deep ones.
So you were sort of responsible for the riverbank then? Yeah, very nice. Okay, Tricia, what do you think will happen then to your plants and rocks when we flood the landscape?
Some of them will get washed away.
Any ones in particular?
That one,
Okay, this one. And why this one?
because it's the closest.
Closest to the edge, huh? Oh, I think you might be onto something there. What about the things that you built, the mountain and the
well-
fence and so forth?
I think the bridges might get knocked away and maybe some fences, but no way the big mountain.
Okay, so the mountain will survive, but the fences might be washed away. And the riverbanks, now they will be interesting. Any predictions there?
Yep. When the water comes through, I think the deep riverbanks will fall down, but the not so deep ones will be all right.
Oh, Oh, very interesting. So you think there'll be a difference between these steeper banks and these shallow banks? Well, I think it's the moment of truth. I hate to do this because it really does look rather special. We'll start gently. Now, I want each of you to particularly observe what happens to the things that you made, because I'm going to ask you afterwards whether you were right. Okay, here comes the water. Oh, it's surviving pretty well so far. Oh no, I can see something happening here. Oh. There we go. Well, this landscape has suffered severe flooding. Were you right, Tricia? What did happen to the rocks and to the plants?
Some of them washed away.
Some of them were washed away, and you were right too that this one that was on the edge, that was washed away, but these ones further away, they survived.
This one got knocked down.
Okay, so this little fence here was knocked down. Yep. What about the bridges?
Oh, they got knocked down.
They were well washed away, weren't they? Now the banks, they've turned out to be really interesting. What's happened to the banks here?
Well, my prediction was actually opposite. The shallow ones got completely knocked down, and the steeper ones stayed up.
It did. I wonder if that's got something to do with this mountain here, helping to build this area up. Do you think that could be something?
Yeah.
But as you say, over here, well, still, I wouldn't want to have built anything over there, put it that way. If I was going to live anywhere, I think the safest place to live in this landscape is right up here on top of this mountain.
Nothing got knocked down on the mountain
Okay.
except for one gate, but that survived.
Very good. Thank you for that, guys.
How hard is a rock?
When you think of a rock, you think hard. Rock hard, right? Take a look at this. I can actually dig into this rock using the trowel. How hard is that? You can see now how a river might be able to actually break into a rock and tear bits away. Well, in fact, different rocks have different hardnesses, and that will affect how much the river can tear into the rock and break bits off.
The hardness of rocks. Here's an investigation you could try. How could you test how hard these rocks are?
I'll just scratch it. Am I scratching any away? Can you guys see whether I'm scratching anything away here?
Yes.
Definitely. So there we are. This one is soft enough that I can scratch it with a fingernail. So if you just mark that for us, Tricia, and we'll move on to another one. What about this one? Where should we start? Fingernail? No, I think I'd break my nail before I made a mark on that. So no, that can't be scratched with a fingernail. Now I've got a copper coin here, and that's the next thing we're going to test with. So look very carefully. Has anybody got the magnifying glass?
Yes.
Have a close look and see if I'm making a mark. Have a close look. Am I making a mark? Not really, I wouldn't say. No? Okay, so this is harder than a copper coin. What about the nail? Ready? Am I making a mark?
Yes.
Yes?
Straight
Just
lines.
a little bit of a scratch. Yes, I think I'd agree with that. All right, so that's just about as hard as the metal nail.
You could test your own set of rocks. Now.
Marnie, do geologists really test rocks this way with a nail?
Yes, we do. We use things like our fingernail, a nail, and other minerals to test the different hardnesses.
And the rocks come in a whole range of different hardnesses. Have you got an example here of a really soft rock?
Yes, I have. This piece of talc. This is a very soft rock, and you should be able to scratch it with your fingernail.
Ah, and there you go. On my finger, you can start to see the talc forming. That's funny, really, isn't it? You don't think of this talc as being a rock, do you?
Well, no, I mean, we see it in the supermarket in packets, but that's where it actually came from.
So rocks can be soft enough to be broken down by water, and that includes the sea as well as rivers. This beach has been eroded by the sea. In this case, it's the sand that's been carried away. Fortunately, the beach has been reclaimed, and now It looks like this.
Where do the rock particles end up? Sedimentary rocks. Rock particles are carried by the water until they fall to the ground to form a new sedimentary rock.
If you were out in the field and you were looking at a new rock, would you be able to tell that this was sedimentary?
Yes, you can. One of the easiest way to tell is you can see that there's lots of stripes or beds in the rock.
And that must tell you something about how it was formed then.
Yeah, basically these things, these layers, come from the different layers of particles being laid down with time.
Are there any other ways you can tell if a rock is sedimentary?
Yes, one of the other ways is you can see this one has fossils in it, and that's these dark things here.
That's amazing. Look at this. All these things have been trapped in this rock when it was formed.
Yeah, sedimentary rocks preserve the record of life from past ages.
Goodness. Now, if you just look at a rock, can you tell anything else, for example, about how it was formed just by looking?
Yes, you can. The grain size of the sedimentary rock can tell you what sort of environment it formed in. This one, for instance, which has a very, very fine grain size, almost like a clay, has formed in a very quiet water environment, someone like a lake.
Little grains were carried then by a slow-moving
By
river.
slow-moving water.
Right.
Whereas this one, for instance, has coarser grains, sand size and sand type grains, and it probably formed either on a beach or in a moderately fast-flowing river.
So the faster the river is flowing, the bigger the particles it can carry.
That's right, and some very fast-flowing rivers can actually carry small boulders.
Amazing.
The types of rock. Metamorphic rock.
Ronnie, you said there were 3 ways to form rocks. We've seen volcanoes forming rocks and also how sedimentary rocks are formed. What's the third way?
The third way is a process we call metamorphic, which means we change one thing into another.
So you're going to change one rock into another kind of rock.
That's right, and we do that by heat and pressure.
Have you got an example?
Yes, I have. Remember our sedimentary rock?
Right.
When we squash that and heat it up, we turn it into this quartzite.
That's a big difference, isn't it? Is this one much heavier, since you said it was formed by heat? Oh, yes, definitely, by heat and pressure, much heavier.
Much heavier, and it's also much harder.
Where does this happen?
It happens in mountain ranges.
So actually underground. So what's happening then is this is being squeezed and heated inside the earth?
Inside the earth, yes. It gets sucked back down into the earth and gets squashed and heated up.
Are there any clues by looking at the rock? Would you know that this was actually a metamorphic rock?
Well, the first one is, compared to its sedimentary counterpart, it's much harder.
Right.
You can still see the layering in it, though, so we can see where it's come from.
Okay. As a very general rule then, now that we've looked at the 3 sorts of rock, can you say something about the hardness of the rock and the way it was formed?
Yes, generally sedimentary rocks are softer than either metamorphic or igneous rocks.
Thanks very much.
Erosion. What has happened to this land? Why?
This is the Darwin Valley, and it's an incredible example of erosion. Look at the way that the rocks have been worn away down the sides of these banks. What do you think could have caused this kind of erosion? The answer is rain. I find it incredible that rain could cause this much damage to the landscape. How is that possible, Tanya? How has rain made this enormous hole here?
Okay, well here at the Darwin Valley, we've got soils that are really easily eroded by wind and rain, and initially the soils were exposed because the trees were cleared away, and so that caused lots of problems.
Okay, so people have come and they've taken the trees away, and that's meant that the rain is now causing all this damage.
That's right, yes.
And what's actually happening to the material? It's getting broken away on the sides here. Where's it going?
Okay, it's getting carried further down the valley and depositing into the Melton Reservoir.
So there's a reservoir at the bottom.
There is,
and
yes.
it's steadily filling up.
That's right, which will cause problems for people who want the water.
Is somebody doing something about that?
Well, lots of things have been tried. As you can see, we've got pipes over there and concrete constructions to try and stop the rain from scouring out more of the soil. But the real key to stopping it is to put back the plants and grasses and trees that were originally here, which protected the soil.
So is there a replanting program happening here?
There is, yes. We've done a lot of fencing to protect the trees that we put in, because we've got rabbits as well here. And we know that rabbits cause lots of problems as well by eating everything.
But the best thing would be not to clear the trees in the first place, right?
That's right, yes.
Thank you.
It starts with a rabbit hole. It grows into a tunnel. And keeps going into this. How many different causes of erosion can you think of? Rivers, sea, rain,
People.
and wind. What kinds of erosion are happening at your school?
These bankments have been eroded by children playing and running water. We've put these fences around it to protect the natural plants. We have used tambark, but it's been washed away in the past. So we've put underfelt there and put tambark on top to stop the erosion. And the plants has also helped us.
Why don't you explore your own school grounds and look for examples of erosion?
What kinds of erosion are happening at your school?
I found an example of erosion here on this bank. Now, what do you suppose has worn away the soil here? Well, it could be the water washing against the edge of the bank. Then again, it could be the feet of those pelicans as they climb in and out of the water.
What is the difference between weathering and erosion?
Weathering and erosion are actually two similar processes. They're linked together. Weathering is what happens in place to the rock by the action of wind and water. Erosion comes in when we start to move those products from one place to another, again by the same processes of wind and water.
In this animation, you can see the difference between weathering and erosion. The rock is weathered and cracks form. Then the rain erodes or washes away the particles.
Find out about weathering by acid rain.
These statues have been chemically weathered by acid in the air. The fragments are then eroded by wind and rain.
Find out more about acid rain.
There's acid in our atmosphere. And because we humans are sending pollution up into the air, the acid is getting worse. Now, this acid can actually eat into the leaves of plants and also into the bricks of buildings. I'm going to investigate just what sort of an effect the acid can have compared to clean water by spraying each of these plants. Now, this one is going to be sprayed with vinegar, while this one is going to be sprayed with water. I'm going to spray each of them every day for a week, and then we'll take a look.
So the material in the earth is churning and reforming. Old rocks are being broken down and new ones are being formed. In volcanoes, rocky material is melted to a fiery liquid and erupts onto the land, setting to form igneous rock or fiery rock. Then there's sedimentary rock, which is formed when tiny particles of rock are worn away and carried by the wind or rain to a new location. Here they build up layer by layer to form new rock. It seems amazing to think of a rock breaking into fragments, but as we've seen, not all rock is rock hard, and even the toughest rocks can eventually be worn down. We've looked at some of the ways the land can be worn away, by wind and rain, for example. Finally, metamorphic rocks, which are rocks taken under the ground and squeezed to form super tough, dense rock. Now, how good a rock detective are you? What kind of rock do you think this is? Notice the layers and the grainy look? This rock isn't that hard. In fact, it's sedimentary rock. Another clue would be fossils in the rock. What about this rock? It's very hard. This rock was formed under the ground, and it is metamorphic rock.
Okay, Berry, now I've got a trick question for you. What do you think this is?
It's shiny, and it's sort of rock-like, but not very rock-like. It's a cross between a rock and tinfoil, right?
Something like that, yes. It's actually slag from a smelter.
So it's not a naturally occurring rock at all.
No, it's actually an artificial one.
There you go. There are actually 4 ways to make rocks then. There are metamorphic rocks, sedimentary rocks, volcanic rocks, and artificial rocks. Earlier in the program, we saw an animation of what happens to a rock as it's weathered and then eroded away by rain. I used PowerPoint, and after the program, I'd like you to have a go at making your own animation. Well, PowerPoint is one way that you could show someone an animation of what happens in the landscape, but there are a couple of other programs, including Microworlds. Now, there's a great help feature with Microworlds, so you'll be able to use it really quickly if you have a go.